Uh,
All right, welcome back, everybody. This is the Virtual Residency 2025 workshop, the 11th annual workshop. It is Thursday, June 26th, and I want to welcome you to our third session of the day, facilitating cloud computing and explaining cloud pros and cons. Our moderator is Tulika Goes, and I'm going to turn the show over to Tulika to introduce the panelists.
thank you, Henry. And I'm Tulika Ghosh. I'm from UNLV, University of Nevada, Las Vegas. So it's still good morning for us. We haven't reached afternoon yet. And today we will talk about cloud, as cloud is also a very interesting topic for us at UNLV. We are exploring cloud as we are starting to build more formalized cyber infrastructure support here. And I'm here to learn from all of you as well. What are your challenges? What lesson learned? As cloud is one way, it gives us the flexibility of scalability. On the other hand, there are other challenges with cost, training, learning, onboarding, and those kind of things. So we will discuss all these things today in our panel and learn and hear from our panelists as well as the audience. So let's start with the introduction first. Pat, do you want to go first?
Sure. My name is Pat Bills. I work for Michigan State University ICER HPC Center. I'm a research software engineer and a staff data scientist. I use cloud computing in my work, and I teach cloud computing to early career researchers.
Thank you, Pat. How about Dennis?
Uh, Hi, I'm Dennis Borokoff, and I own a small business called GIS CAD AI IT Services, and I have years of experience in the computing space, geographic information systems, computer-aided design, and artificial intelligence. I've been mentored in some of these as well by industrial experts.
Thank you. Jacob?
Yeah, my name is Jacob Fosso Tande, and I am a research computing architect and solutions developer at North Carolina State University. And in my role, I'm not just limited to cloud computing, but everything that is available and that I can make use of to address my users' need. So building cyber infrastructure and cloud computing is one of the tools in my toolbox.
Thank you. Uttam?
Yeah, good afternoon. My name is Uttam Ghosh. I'm working at Meher Medical College in Computer Science and Data Science Department, and I'm working in cybersecurity and cyber infrastructure more than 15 years. And presently, I'm attending summer research program at Rome, City of Rome in New York.
Nice. Thank you. Tom?
Hi, everyone. I'm Tom Arce. I'm the Senior Technology Integration Specialist in STEM at Washington and Lee University. And we're a small liberal arts college of under 2,000 undergraduates. So I work with cloud computing to help support our faculty and students in a slightly different role than what some other people might do. So hoping to help provide a perspective on that.
Thank you. That's interesting. Ken?
Hi, everyone. I'm Ken Taylor. I'm the cloud architect at the University of Illinois, Office of the CIO. We provide the three major cloud vendors to the university and do a little bit of everything for everybody.
That's wonderful. Thank you, Ken. So maybe we can start with a question where I see maybe Ken and Pat and Tom, you it's more relevant to you. You guys have seen a lot of researchers with different understanding of cloud and they come from different background. So could you share some of that experience, like what is the breadth and what kind of expertise have you seen in the researchers who reach out to you with a request for cloud, and Uttam and Jacob can also join and share their perspective from a researcher perspective of how they see the bandwidth of the cloud and the different understanding of cloud. Who want to go first? Pat?
Sure. I have helped researchers use cloud and build on cloud, and as I mentioned, I teach early career. And the breadth, of course, is all over. We have people coming into our class who've already have accounts and have worked for commercial companies, and we have people from a non-traditional HPC college, like College of Ed, social scientists, et cetera, who have very little IT experience. And the major hurdle, I would say, for approaching cloud is lack of IT literacy, because the cloud is written in terms and metaphors used to enterprise IT that most researchers are unfamiliar with. And that's my main message to the students, is that you need to acquire some of this if you want to understand this world.
How about Tom and Ken from your perspective, and then we can hear more from Dennis, Jacob, and Uttam after that.
So it's very interesting at the undergraduate level. We definitely run into the situation where many of our researchers and certainly our students don't have any familiarity with things like terminal and being able to work in a Linux environment. So cloud computing actually ends up being a great bridge for us, where we can set up Windows environments that they're used to working in, especially so they can continue using software that they're comfortable with. And likewise, we can help them work with graphical Linux systems like Jetstream. What we do need to do a lot of times is we need to do the configurations from our end on the IT end of things. And then we set up everything, install system dependencies, things like that, so that the researchers can really just get in and start doing their work. They're the subject experts, we're the IT experts.
From my perspective, we've seen mostly the issue of I have it running on my laptop, I need to put it someplace else. I have too much data, I can't do it on my laptop, I need to do it someplace else. So that's where we tend to help people most in getting stuff up and running. However, I will say the majority of researchers have, a small army of graduate students available to them. And that's what we recommend to people. We say, "Oh, you got to go get a grad student, somebody who can do some Python. They don't have to know the cloud, but they should know about systems, etc." And we see that as a much better alternative than trying to train up a researcher who's, you know, heads down into their research that they don't really want to bother with that sort of stuff. And so having those graduate students who are, of course, less afraid of the cloud and willing to jump in works out really well for everyone.
Sounds good. Dennis, do you want to give your perspective, as you're a little bit from a different background?
Yeah. Yeah. From my perspective, the cloud has been useful for off-site backups, although sometimes the cloud can go down in certain scenarios. So sometimes I've been, maybe pondering a NAS, network attached storage, so I can have some, extra little bit on, the side, just the computer with some
Yeah.
hard drives and stuff like that.
Yes, for sure. And also other institutions where I have worked, they use a lot of the cloud as their backup, as S3 is something that's available, and for archival purposes, it's sometimes easy to just quickly set those things up. How about Uttam? Do you want to share some of the background of your cloud usage from your perspective?
Yeah, so obviously, I'm working at Meher Medical College. So we have different challenges. So first challenge is security and compliances.
Right.
Especially we need to follow the HIPAA policy. So there are several challenges. Second challenge for our students we are facing, that is reliability and the cost. So reliability means, say, if you are teaching a course and if you are using cloud like AWS, then it will be costly. And sometimes NSF, they have programs, NSF Axis, they have Chameleon, another project they have. There you can get the resources freely, but the concept is leasing. So you will get 1 month up to 3 months. You can request their resources freely. You can use their resources for your classroom, for hands-on experiments, even for research also. But again, the main concern will be reliability. Say sometimes some research may be maybe more than 2 years, maybe 3 years, and some courses are there we are teaching whole semester, then same material we may need for another semester. So it is a continuous process. So sometimes reliability will be the question there.
Yeah.
That type of challenges we are facing.
Yes, and at here and also other institutions where I had worked, uh, most of the compliance environment, we use the cloud because it was a quicker way and easier based on the how we have limited resources to set up like the GCC high or a HIPAA compliant was mostly in the cloud environment and maintaining on-prem and maintaining all the certifications. Jacob, do you want to share some of your perspective?
Yes, from at NC State, so I do attend to researchers, most of them interdisciplinary, so they come from various backgrounds, agriculture, engineering, biotechnology. And so my interaction with them, sometimes they already come to me, they've already started with cloud environment. Sometimes they don't have any idea of what they want to do. And whether I use cloud or not is determined by a certain number of factors. So what do they have as budget? What is their data pipeline? What do they want it to look like? Where is the data coming from? Do we have any alternative? What about the labor that they need? If they don't have the required labor, it may be an opportunity to use one of the public cloud provider where they already have infrastructure that everything's taken care of. And then you weigh in the budget. So does the budget fit this model? If it fits, then you have a discussion, short term, long term. But if you don't just want to quickly run through some data, get some quick information to inform yourself on what you will need, yeah, we'll set up something for you so you can play around with it.
Yes, and I think that brings me to my second question and how Jacob was sharing, like they come with different background. And also like within commercial cloud, each cloud have its own, I would say, terminology and way to configure things. So help us understand what are the different trainings that are helped as like your cloud engineers or the facilitators to get trained, and also the end user, the researchers to get trained on some of those resources when using cloud for their research. So, Jacob, do you want to go first as you started sharing the people coming from different background, how you approach that, or any training that has worked so we can also understand and maybe leverage some of those resources?
So as far as for me personally, training is self-taught. My background is actually theoretical chemistry, but I've gone into cloud computing just by curiosity, and I've learned a lot. And attend seminars, workshop, webinars on the net, free tier usage, and build things around. But as far as the researchers go, which is really where the focus is, um, so the training can come in a number of ways as I do my job. So I'm mostly focused on building platforms for researchers, especially people who have a lot of sensors. They collect data on the edge, and they need to process that data and then share with stakeholders. So whether it's production chain for sweet potato or some nematode somewhere that they're collecting and they want to have data on that. So I don't have the labor force to do all of that. I have an applications developer, and I, as a solution architect, I will design the solution. The application developer will build, but we will use infrastructure already present in cloud. On the long run, we will need people to do the maintenance. So this is when we bring in graduate students, postdocs, and some members of the PI team. And so we set up a workflow to integrate all these ingredients into it. So if we're doing applications development, we set up a DevOps pipeline where if you make a pull request, where the application developer has to review what the work of the graduate student or the postdoc and make sure that they're following the guideline because we create documentation at the beginning. It's actually a training. An ongoing training. So we give them basics, we get them started, and the application developers start building the templates. So they start working on it. We train them to a point where they get to a point where they can add some code to what we are building. And so they do that, and then we go on and take other projects. So we are training and building infrastructure at the same time because we don't have the money to hire all the people that we need. As far as the faculty is concerned, so I think most of the time when they come to me, it's usually a money problem. So my storage is full on OIT storage, and if I want to add up, they're asking me this amount per month. Can you do a price analysis for me and compare what Azure has to offer, AWS has to offer, and what OIT has to offer? And then I look at the type of data that they want to be doing. Oh, well, maybe we'll use university storage for your hot data. And since most of the time, for a very long time, you haven't been accessing your data, we'll move all of that to S3. And so we'll set up a pipeline to do that for them. Or we build a database, or we set up one for development, one for staging, and then one for production. So we build all these processes and we evaluate the cost and let them make the choice. If they make the choice, which most of the time for archiving, it's AWS S3 Glacier. And then hot data is on our OIT storage. So we use a mix of things, both on-site, on-prem, and public cloud, even the private cloud at our institution. Sometimes the pricing at our institution favors the institution. We'll use what our institution offers compared to the commercial cloud. I'll take example of a graph database, for example, Neo4j, which well managed, you pay probably, I don't know, 15,000. Whereas if we get a virtual machine on our private cloud and install that application, free version without any license, it's not anywhere close to that. Plus, we are still doing development. We don't even understand. We don't even know whether we'll need that. So once we keep building to a point where, oh yeah, maybe we need something which is managed, then we can go for that. But now what we are doing doesn't warrant the expensive price tag provided by that cloud provider.
Yeah, for sure. We will talk about cost in the coming up questions. Let's tackle the training part and understand how others are handling that. How about Pat? Do you want to go next?
Yeah, I'd love to. So for the past 6 years, we've offered what we call the Cloud Computing Fellowship to grad students and postdocs to try to bridge that gap. These are the folks that Ken mentioned that are for the labs to help build things because we don't really have facilitators on our campus at this point. And we have decent HPC, actually excellent HPC services available for computational work and storage. But for training, we started with Azure and I wrote all my own materials to try to bridge that gap between IT literacy because I noticed all of the materials have as a requirement knowledge of IT systems, which most researchers don't have. So, but I found that, as Udom mentioned, it changed frequently. There was no consistency, and so it was very time consuming to maintain labs and the training to match what the service offering was. It's hard enough to maintain our own infrastructure as code, as you probably know, when you go to run something and suddenly it doesn't work because they've changed the service. So imagine how frustrating that is for new learners. So this year we switched to AWS, or last year, 2024, 2025, to AWS. They offer something called AWS Academy, which is free. And if you sign up and do the train the training certification, and that way they maintain the training. And my job then is to offer more soft training, which is the translation to bridge that IT gap. And then their solutions architects have offered and have done training for us, tailored to what we want, which was a game changer for us. We were able to train 60 people in the fall instead of just 15. And then in the spring, then when we of the project phase, then we had made that competitive and allowed 10 to 15 participants, full accounts with a budget that they could then build what they wanted to build. And that's been really successful for us and for the participants. It's a small number of people, certainly, but it's been educational for them and also for us as we see what they try to learn and what they try to build. We learn appropriate workloads based on what they find value in the service.
Yeah, that's wonderful. And I did learn recently about the AWS Academy and trying to learn more about that. And thank you for sharing your experience with that. Ken, do you want to share your perspective on training?
There we go. Yeah, we have a number of faculty who are using AWS Educate in the classroom. And so that's been very successful, and we've gotten really good feedback from the students. So they really enjoy it, very hands-on. I also put the link to AWS Educate, which is completely free, self-paced education. But you have to remember that AWS Educate is for the classroom, and so you have to have an instructor who is actually teaching a course related to cloud computing or whatever research they're doing in that particular department. But I would have to say Educate has really proven to be very helpful. I'll also echo the use of AWS Solutions Architects. Um, the thing to get people started is to sit down with someone from the vendor and and just do a workshop session of, a couple of hours just to get them going. You know, have that person do all the typing while the solutions architect says, okay, now we're going to build this, now we're going to build that. They actually see it coming together. I think a lot of people are intimidated by the large box of Legos that they're facing when they come to a cloud vendor. They see all of these things, but they don't know how they fit together yet. So they can pick up a block, but they can't make the block do anything until they stack it on another block. So it is daunting to say, oh, I've got 200 services in this cloud. Where do I start? Well, we're going to start you very simple. We're going to just talk about compute. We're going to talk about storage. And then we'll talk about databases. I mean, just get the basics out of the way. And then they start getting a little bit more comfortable. But we've had everybody from grad students to PIs having to get that hands-on first session going. That really, really helps everyone.
That's wonderful. Yep. And it's that what I have received feedback from the researchers, like they get lost. It's so much, even though they sometimes try to get like a P card, get an account, and then they are lost. They are trying to find help from the central IT, and then they reach out to us. How about Tom?
So I'll reemphasize what both Ken and Pat have been saying. We use AWS Academy as well. We use their learner labs a lot, which actually do let you go a little beyond that structured curriculum that they have and use it for some more experimentation, which is nice. And the solution architect that we have has been extremely helpful. One great thing, especially at the undergrad level, is Amazon has done a lot of proof of concepts for us, where they will actually give us credits and they'll work with us on a research project with the solutions architect doing all the development of the workflow, the architecture, and the training for the people working on that project. So that's been effective. Then the other thing where we're a little different being a small institution is the rest of our training is very much one-on-one. We do get to have the time to spend with each of our researchers. And I say we as the royal we, it's really just me. Small school, but it is nice to have that opportunity. You really get to know the researchers, get to work with them, know what their problems are, and be able to step in when they need help.
Wonderful. Dennis, how about you from your perspective, as you are coming from a different perspective here?
Yeah. Well, I haven't really trained anybody on how to use cloud computing infrastructure because I'm like a, kind of a small company.
I see.
But I have say that,
How was your training? Like, when you were trying to use cloud to set up maybe infrastructure for your company, did you use any of the cloud and uh, found out some training to be helpful for yourself?
Are you talking to me?
Yes.
Oh yeah, well, I've used multiple cloud sources and they're all pretty decent, but I tried to use the cheapest tier that I can get away with. I'm not a college which can afford the $10,000 tier and stuff
Mm-hmm.
like that. So, and they're pretty decent, but sometimes, and I have my sites bet on the free tier. I have some on Google Drive, I have some on Dropbox and stuff like that. But yeah, that's what I do to try to, save as much money as I can. But yeah, the cloud is pretty good, but when it goes down, it's bad.
Yeah. How about you, Uttam? Did you use cloud or received any training from your
Yeah.
university?
Yeah, actually, we are using cloud, especially in three cases. So we used to organize boot camp. It is that is yearly basis. That is
Mm-hmm.
free boot camp freely, and that boot camp is for undergraduate and graduate students. Most of the students from Meher Medical College, Vanderbilt, Tennessee State University, Fisk University, they used to join, and there our main goal is to teach and train students for using cyber security, cyber infrastructure perspective. So there we used to use cloud computing, some tools, and also in our master degree and PhD program, we have some courses related to big data management, and big data security. So there also we used to use cloud computing. So we are actually using both concepts. So we are using cloud computing like AWS,
Mm-hmm.
just tools like MongoDB, DynamoDB, we used to cover there. And
Mm-hmm.
at the same time, we used to install those tools in our local machine. So both way we used to teach, because again, the problem is we may not rely every time on AWS. So that's why we are using both approaches. We are using cloud as well as our own local platform. And in addition to that, we used to organize monthly seminar series, because Meher Medical College, most of the students, their background may not be cyber security or may not be cyber infrastructure related. So we used to organize monthly seminar series. There we used to invite faculty, industry people. They used to present how to share data in healthcare domains, because we need to follow HIPAA policy, how to use infrastructure, how to use cloud computing. So that type of seminar series we used to organize a monthly basis. And yeah, this way we are actually covering all those things.
That's wonderful. That's a lot of great ideas. And I think now my next question goes, what kind of research projects or workloads do you find more suitable for cloud? I know, Jacob, I will start with you as you were talking about you guys use both like on-prem and cloud. So how do you decide which one may be the good use cases for a cloud environment versus setting up something on-prem? And AI coming in, that becomes more, I would say, complicated, or we are learning a new space to understand which of the things we need to run it on the cloud versus set up something on-prem. So Jacob, let's start with you as you shared some of that hybrid infrastructure, and then we will learn from others too. What kind of research projects or workloads or different workflows you have set up that you find very efficient for cloud kind of use cases?
Yes. So I would say that whether you use cloud or not, I think everything start up being what is your workload, especially
Mm-hmm.
compute workload. So, and then at what stage of your research are you? I don't think a computational chemist, which is my background, still trying to understand a molecule, will spend all the time in on a virtual machine installing, I don't know, Gaussian or NWChem to try to reproduce some result. How many times would you reproduce that result before you burn all the credit that you have at your disposal? So most of the time, whether I go for cloud is okay, I'm already at the production level and I think I can deploy this permanently. That is one option. The other option is the computation involved. Is it light computation or intense computation? CPU intensive, IO intensive? How huge is that? Well, if it is very intensive, I think HPC is the place to go. Let's use our on-prem infrastructure. If it is just, okay, we are doing computing on the edge, we have some edge infrastructure, we collect the data, we do the extraction, machine learning, we just want to get some information. Extract, move into a database, build a dashboard, and then share with the stakeholder. So that is an ideal, in my perspective, case for a cloud, for using cloud infrastructure. Azure, for example, has static web app that everything is already present there. You have DevOps right there, right next door. You have your GitHub repository. You can build a pipeline straight from the edge onto the cloud, a dashboard for your researcher. That is a classical use case that I have seen. The other use case is long-term archiving, especially data. So research data, and if you look at the research storage at your institution, the data start up being hot, and then after a while, it's cold, and then it freezes. So, but they don't agree that you need to move that data. All you need to do is bring the information, the log from the data, and show them, hey, you've gone 2, 3 months without touching this. This shouldn't be here. So if your university is charging for storage, they start up having a free tier. And then when you fill it up, you go for more, they say you pay. Now you compare the price for what they're charging you to archiving, I don't know, AWS or Azure, there's no there isn't a match. So we'll push it there, and then if you need it, you'll find time to break it back and then make use of it. We'll use your institution storage for your hot data, which is what you need right now. And so then I think one other very interesting thing is the databases. So at our institution, for example, we didn't have anybody with really good knowledge of how to set up a database, adapt it for this project or that project, which one should we choose? We can go off and educate ourselves, but setting up a database that works the way we want, it's not going to come right now, but I need that database right now. And the only place I can get that is either AWS or Azure. And they provide managed database that you can get access to. So now, if I compare my Azure infrastructure with my on-site cloud, the difference is, well, I can do a hot upgrade, horizontal upgrade, right there without having to worry about, okay, I'll take the snapshot and all of this. My institution may offer a free, low-cost VM for my database, but if I get to a point where I need to increase the size of my database, it's going to take some time.
Mm-hmm.
Whereas in cloud, well, I can just go in there and change the parameters and then get more storage on my database, and that solves the problem for me. Plus, I can start up really small in cloud with my database, understand the need before I scale up. So scaling, if you want to scale up, start up, try to understand what you're working on, especially if you have a workload that is adapted for that you've identified. It's a good place to start with development, understand the parameters, and then scale. In my case, I had a number of projects, one data source, it's hard to build that data source. And you have another 50 data sources, but they are all related. So that first one is a template for me in the cloud. And if I get that right, the next 50 is just click, go, little modification, actually a pipeline modification, and everything is set up. And they have the same thing all across. And you can do code refactoring without having to worry about what is going to happen. Yeah, so that is my experience.
That's wonderful. Thank you for sharing that. Ken, do you want to go share your perspective on which workloads or
Absolutely.
what type of research projects work best?
Yeah, absolutely agree with Jacob's comments about databases. We've actually been trying to move all of our databases from on-prem to the cloud. It simplifies the maintenance. It eliminates the licensing because now we're using, free license software. Um, and the researchers can start and stop a database as they need to, to do something. Um, uh, I'll add on to that comment about serverless. The big cost with any computer is how long you run it. And transitioning from a I bought a machine and it's running under my desk and I can use it whenever I want is not what you want to do in the cloud. You want to go serverless. You want to run your job, stop the machine. So in explaining this to people, and really there are lots of people who don't understand serverless. There is a server, but you're just not running it 24/7. You have a program, a piece of data may arrive, such as a file in S3, that creates a trigger, that runs your code, it processes the file, and off you go. And and so we had a pretty large project at the university that we did completely serverless. Um, it was basically that. It's a pipeline where a file arrives, a Lambda function, all in Python would kick off and do several steps. We had several iterations of S3 bucket, Lambda file, another S3 bucket, another Lambda, and so on. Um, and that entire system, which still took us a while to stand up with all of the code, only cost us between $500 and $600 a month. And we ran that, several times for several years. The point being that it would have cost, $10,000 to go buy a dedicated machine, install it in a data center someplace, configure it, get it up and running, maintain it, update, patch it, all of that stuff. We didn't have to do any of that. In fact, we hired a person to support the pipeline once we built it, and they had nothing to do because the pipeline just ran on its own.
Wow.
And so we could turn our away and focus our attentions on other more important things because the system essentially it just ran by itself. So serverless is like once you get past the compute, the storage, and the database intro of a cloud, the next thing is you've got to go serverless. And we're seeing databases that are serverless. You're only paying for when you read or write the data to the database, and then you're paying for the storage. So the storage is usually relatively low cost compared to how much interaction I'm doing with the database. Um, S3 is serverless. When you want the data, it gives it to you. And so, oh, and of course, now we're getting the question about cost. Pay as you go is yet another one of those transitions that you have to make, right? You write a grant, you get a pile of money, you go and spend it, you're done. In the cloud, you write some code, run it, see what you get, run it some more, and you pay for that privilege of essentially using their computers on your own time. That pay-as-you-go model is really hard for people to wrap their heads around, even harder for the university financial system to wrap their heads around. And so we get a lot of pushback for people saying, "What do you mean it's different this month?" It will be different depending on how much data you have, how much processing you're doing, how many people are coming to your website, et cetera, et cetera. So learning serverless and learning pay as you go is really, I think, the two biggest steps that have to be accommodated with researchers.
Nice, thank you. That was very nicely put together, and it helps a lot of people to understand the benefits where cloud helps in the research and research pipeline and workflows. Pat, do you want to go next?
Yeah, I'd love to because I want to follow up, and I completely agree with what Ken has said. Um, I tend to send people to the cloud for service gaps, things that our university doesn't offer, our HPC does not offer public facing or long running systems, server based systems. Our institutions has virtual machines as a offering. You could buy a virtual machine, but now a researcher has to install everything they need and maintain it because we don't have that kind of support for researchers. So serverless in the cloud and what's called platform as a service type services, those two things are similar, and that the idea is to have the researcher focus less on infrastructure and more on what they need to do. So I'm a solutions architect at AWS. Lou Cody said there are people who see the cloud as a place to be, and that's the IT people, and people who see the cloud as a place to get something done, and that's our researchers, right? And so I focus on that. And so in my training, I focus on platform as a service. I don't teach networks other than the minimal security groups you need to know, because people don't know that stuff to begin with. And so I try not to teach, or I don't emphasize virtual machines. I emphasize what do you want trying to do? There's bound to be a service from the cloud provider that provides that. Databases is a great example. And as a database programmer, it changed my world because MSU doesn't offer that. And I was tired of running my own on-prem. But in addition to the other data services like BigQuery, where you don't even have to spin up a database. You just start managing your data, or we've also used Spark as a service, Databricks, where you just turn it on. You don't have to really install anything or build any services. You just start using the service. Those kinds of things are really appropriate. And I'll keep it short, but one thing I do want to say is that our participants in the Cloud Fellowship have to write a proposal. It's competitive. And many of them will say, well, the HPC queue is slow and I want to do HPC in the cloud. And we tend to rate those proposals down because we want to see use in the cloud other than compute, because Access CI provides that for researchers. So what sorts of things can students use that MSU doesn't offer, or universities don't offer? And I'll leave it at that. Thanks.
That's nice. Thank you. Tom, do you want to share from your school perspective?
Sure. So cloud computing is a great fit for us at the undergrad level. One of the main reasons is accessibility. When you're at an undergraduate level, our researchers are dedicated primarily to the teaching environment. They have very limited time to actually conduct their research, and they all basically have the same time in the middle of the summer. And so what would happen if we were using an on-premise cluster like we've had in the past is that entire system would get saturated at that point. You'd be waiting for long times in a scheduling queue, and you wouldn't be able to get as much work done over the summer. And then the rest of the year, those resources would just be not being used very heavily, and they'd be aging out. So cloud computing gives us the ability for our researchers to get access and start working with those systems as needed. No waiting involved. They just start doing their work. The other area that helps them on a time savings is not only can you scale up in cloud computing to have more powerful resources, but many of our researchers end up scaling out so that in addition to, instead of just having one machine that they can work on, very frequently we'll have them spread out to 10, 12 different virtual machines that can do the same thing simultaneously with maybe a variable changed. And you can take a data run that might take 2 times 2 days per run. And instead of having that stack up to be a month worth of runtime, you can have it all finish in 2 days. So that's one of the huge advantages there. The other thing that we see is it gives our researchers the opportunity to work with newer technologies that we simply wouldn't be able to implement on campus. One of the biggest areas of that is in quantum computing. We've done quite a bit with our researchers and students working in the quantum environments, and systems like Amazon's Bracket gives us the ability to do that, as well as some of the free resources through IBM's quantum experience.
Yes. And I know like a lot of schools are collaborating with IBM, setting up their more undergrad teaching, as well as some of the proposals go with undergrad teaching as well as research. But IBM is very focused on the teaching when the proposals or the requests come to them. So, Uttam, do you want to share your perspective? What has worked for you? What are the good use cases for cloud?
Yes, so first I will share this. We have high performance computing resources,
Mm-hmm,
and Mehri Medical College is 150 years old. We have lot of healthcare related data, old data also.
mm-hmm,
And earlier we used to use third party for managing the data. Now we are in the campus, we have data center, we have high performance computing resources. We are migrating those data inside the campus, and there we have a department. It is a sister department of our school. It is called EDA, Enterprise Data Division Analytics. So I'm also working as a cybersecurity specialist. So there, our goal is to migrate the data from cloud to our own data center in our own high performance computing resources. And in addition, in my lab, so as a faculty, as a researcher, first when I joined at Mehri Medical College, first I wrote a grant around $60,000, but that grant was related to infrastructure.
mm-hmm,
So using that grant, so that grant was National Security Agency. We got the grant and then we purchased 4 5 servers, or better to say workstations. One server is acting as cloud, and then rest of the workstations are working as edge servers. And then at the bottom, so just we are following the 3 layers concept there in my lab. So at the bottom we have IoT layers that include say laptops, then surveillance camera, and then some Raspberry Pi. And then we integrated with the concept of software defined networking, so that using same lab, same setup, we can do a lot of experiments related to any kind of cyber physical system. That includes healthcare application, that can include electric vehicle, highway communication, or that can be even smart grid communication. Only thing is at the bottom, that IoT layer, there you need to feed the data based on the application. So basically that is the concept of virtualization. Same network you can apply for different application domains. So that lab we have. So far we used software defined networking. There we are using Open Daylight Controller. Now you may know another concept is there. So at the top of SDN, that concept is called IBN, intent-based networking. So earlier SDN was programmable. So through SDN controller, you can write the program, and based on the requirement, based on the application, you can configure and manage the network. Now this IBN concept is actually even at Air Force also. When I came here at the time, they are also using, because it is totally based on the application. So as a programmer, you can write the program at the SDN controller. But this IBN concept, there is there is also a controller. It is called IBN controller. So there you need to write the text, like say I need some security, or if I'm working at Mehri Medical College, I need to follow HIPAA policy. So when we are transmitting the data from one device to another device, or whenever we are storing the data in the database, at the time we need security. So for that, uh, at the IBM controller, we need to write that. So okay, so I'm transferring data from one database to another database. I need security. So this will be the input, and that input will be converted into policy. So that IBM controller, now thereafter it will take care. So there are 2 phases, I think. So that in each phase, first it will check validation. If validated, then this policy will be implemented. So thereafter, actually, that concept is what you want. How we are implementing that doesn't matter in IBM concept. So that part actually now we are working. So that is there. And then recently we collaborated with Harvard University. So I'm sharing this link. So they have SB Grid. So SB Grid, that is their cloud. So it is related to I think biomedical data sciences. Whoever is using whatever the tools they need, whatever the data set they need, they can get from the SB Grid. But the issue is still they have security issues. So that's why we collaborated with them. And there, whatever the tools we are using from SB Grid, the user can give the feedback. So based on the feedback, we are improving the security aspect there. And from NSF, we got multiple funding. One funding was related to assisted living. So assisted living, you may know. So we are using wearable device for monitor them. But the problem is some people may not prefer to use this wearable device 24/7. Some people may think, oh, irritating. So, but in that case, alternate solution also there. We can use surveillance camera. But when we are using surveillance camera, the issue is the HIPAA policy. We cannot show the face. And also, if anything happened like fall detection, heart attack detection, mood detection, those type of event also we need to detect as soon as possible, and we need to generate the alert. So for that, we are not using cloud computing. Basically, we are using edge computing. So that's why at the edge server, we integrated the AI machine learning tool. And also at the same time, we are following the HIPAA policy. There also we are using some privacy preservation tool like federated learning, differential privacy, and that for validation in our lab, we purchased some surveillance camera also. So for validation, we are using that concept.
That's very nice to understand the difference, like how the use cases differ from the edge computing to the cloud computing. Thank you. Dennis, do you want to share from your GIS product that you manage? What use cases have been helpful for cloud?
Yeah, from my perspective for cloud, one of the most helpful points has been able to push out like a new update to a project very quickly, or also backing up certain parts of a project that I've just finished. Like if I've finished a complicated bit of geoprocessing that's taken an hour, I don't want to lose it. So a great way is I've used the cloud is to back up certain parts of it whilst trying to keep the PII in check, which is personally identifiable information, stuff like that, which is always why sometimes you have to look at the privacy policy of your cloud providers and stuff like that to check that they're able to protect it appropriately, and check the leak history of your cloud providers to see how much they've been leaked via cyber criminals and stuff like that. So yeah, I can say that from my perspective, that's been the most useful parts of the cloud, backing up and pushing out data to my clients.
Yeah, that's wonderful. Thank you. And let's talk a little bit about the cost and how at your institution you manage cloud cost. And maybe we can add up with, were there any challenges from the researcher perspective, as Ken was saying, they don't understand the this is a little bit different how things are budgeted here. And have you guys like anything that you have done to make things easier for the researcher to understand, or build something with your financial team, like a tool or something, or anything you shared, like to assess out of all three cloud, this may be the way to go based on what their budget have. So let's talk a little bit about cost, budget, any challenges or anything that you have done have made things easier for the researcher and also the institution to understand. So Ken, do you want to go first, as you started some of these conversation, and then we can go around the panelists and everybody can share their thoughts.
Sure. From the cost perspective, uh, uh, everyone will say the cloud is more expensive than me buying a machine. And they are correct. If you buy the machine, it's yours. You can own it for as long as you want. That's fine. But you're not taking into consideration maintenance, software updates, the electricity, the cooling cost, the facility that it's in that has locked doors and is protected. Um, all of these things. Oh, and let us not forget, my cybersecurity friends would be pretty mad at me if I didn't say, as your machine ages, it becomes less secure. And so you have to keep all of that security going for your machine. So there's a lot of that extra stuff that you don't have to take care of. And that's what's really appealing to the researcher. I spin something up, I run my stuff, and I'm done. The next time I come, that machine is already updated. They've got the latest OS, they've got all the security stuff, so that's fine. Um, you know that, for example, AWS has some of the best DDoS protection. There have been major players in the world trying to take down AWS. They haven't been able to do that. So your system is being protected by a lot of people who are being very clever in how they construct and protect these environments. Um, Now, that being said, you have to then convince them to do things in a different way, right? You may have a batch system and you've got to have all this data in memory. You're like, can you chop this up a little bit? That's really a key where you can start parallelizing it. Um, we just had a conversation with another researcher the other day who had that problem, and he had been thinking about how he can divide it up to in order to get parallelization going, but had yet to do it. And he was at odds because the really big machines are never available, right? They're being used by people who have way more money than you. So if you can use the smaller machines, you're much better off. And if you want to use a lot more machines, you're much better off using smaller machines. Um, if you have a data set that requires it, 6 TB to be in memory, you can find those machines. You won't be able to afford them, but they're there. So you have to be very careful about the fact that I can't get access to things because they're just already too busy. Um, the cost aspect, we have seen more people create their own AWS accounts, play around with it, but they're doing it outside of the institution. And there, yeah, see those heads nod. You don't want to do that because within the university environment, we have an agreement with the cloud vendors that give us discounts, access to support, access to other, features and functionality that you can't get in the free tier as you start something up in the other instances. So um, we want you to come into the fold. We want you to give you that help to get started. We want you to take a moment to think about breaking down your system so you can exercise it better in an environment that suits your needs. Um, and and then we have to really get you going uh, in the pay-as-you-go model, right? So always start small, right? Don't try to run your big batch job on the biggest machine with all your data. You want to take and start small so you can actually see that you can scale this up over time. Then we'll worry more about the pay as you go because your department's going to come and yell at us for spending all the money on the grant. So, overspend, yes, overspend is a huge problem. That happens all the time. And we can go to the vendor and say, look, this person made a mistake. They left it running. They shouldn't have done that. Can we, get some of those credits back? And then they're usually very accommodating because most of the time the overspend is a mistake. So, but yeah, you don't want to see these 5, 6 figure overspends. They're painful for everybody. But hey, that's my soapbox. So on to others.
Yeah, can I ask a follow-up question? So I know some AWS provide some features where you can set up like if system is idle, like shut it off. Like have you guys used any of those
Oh, yes.
features to help
Yeah.
the researcher? Because then
Yes.
it makes things easier for the if the graduate student forgot to just bring down the system after running the computation.
Yeah, there's settings like if you reach, 5% idle time for 30 minutes, it's turned off. Um, we've been making more use of threshold alerts. So set up an email chain where a group of people get the same email that says, "Hey, you've spent 85% of your monthly budget. Did you really mean to do that?" Um, of course, we've gotten the questions from the researchers. Hey, I went over 100% of my budget this month. What should I do? Turn it off, right? Just turn it off. It's like get used to the fact that this machine is not running 24/7
Right.
for you exclusively. Turn it off. Don't just log out. Turn it off. Suspend the machine, stop the machine, delete the machine.
That's very nice. Thank you for that advice. Tom, do you want to go from your school perspective?
Sure. So, like Ken, we definitely take advantage of those threshold alerts. One thing that we've done for our threshold alerts, we do 80%, 90%, and 100% for our warning messages. And we tie that to the budget that they've already allocated to their AWS funds. And what we've been able to do by working with our third-party vendor that provides us with our AWS accounts is we're able to do pre-funding. So one of the big things is our faculty need to have something expensed by a certain date. So they're able to put in several $1,000s into an account, and then that money it's spent, but it's there ready for them to just kind of slowly whittle away. And we did learn about the thresholds kind of the hard way. We did have an account that was very nicely pre-funded, and students left the machines running, and they ran out to about a five-figure range. So for those of you listening, learn from our mistakes and put in those alerts so that you don't have the same ones. But definitely highly recommend that you do the alerts. If you do that, that's going to help a lot. The other thing we also use is we do a control tower system. So all of these accounts are set up by our primary IT staff. And that way there's a little bit of an umbrella control so that if someone's account credentials got lost out or anything like that, everything could get locked down so that you don't have anyone unauthorized getting into systems, things like that. Very bad idea to have faculty members creating their own personal accounts and putting in a university credit card or something like that.
Yes, and we all struggle with that. How about Pat? Do you want to go next?
Yeah, that's the first thing we teach in our classes. You make an account, you set up a budget immediately, and I'm on the email chain to try to manage that because there is really no way in the cloud for them. They have a system where they'll delete the VMs, but that's clearly not what we want. In terms of cost, I was going to suggest for that university discount. I see Bob Flynn is on the call. I suggest talking to him about what Internet 2 offers through the Net Plus program. And I'm not part of that equations, but I do know people who use that. The other issue is in terms of not cost control, but selling more expensive platform as a service type systems. Yes, running a database in the cloud, a SQL database, is more expensive than buying a box or a VM and installing it. But to me, the metaphor I use is car insurance or house insurance. Yes, insurance is not cheap, but that's what you're paying for when you're paying somebody else to set it up for you, because it's way cheaper than what the cost of a breach would be. So there's that, and I'll leave it at that. Thank you.
Thank you. Jacob, do you want to go next?
Yes. So I'll first start by specifying, because I see people discussing a lot in the chat about, oh yeah, that's very expensive. So the general question that I ask myself is this the best option that I've got, given all the resources that I have available to me, whether it's on-prem, cloud, or even the HPC? So is there any way, any other means for me to deploy this and still get a cost-effective system rather than going to the cloud? So I go to the cloud when I think I absolutely have to be there. And sometimes you can see the cost and you go, oh, that's too much. But if you look at all the parameters, it makes sense to be in the cloud. And so talking about cost optimization, I'm not going to repeat what everybody has said with auto scaling, auto shutdown, budget alert, but there are other very tiny things that you can do. Researchers are busy and sometimes, and most of the time, they're not very much interested in infrastructure. They want to do the science. So what I do is I have a lot of systems, a lot of projects that I overview, and I can't control all of them. The simplest way for me is to either get a postdoc or a graduate student in that group and train them up to how they can be like the cloud administrator for that group. So everything goes through them rather than having people creating services left and right. And then the second thing is using tags. Quite a lot of the time, what I've seen is the PI has money, they get a resource group, they add graduate student, postdoc, and they just create VMs left and right. You have no idea who is doing what. But if you insist, and the policy is, if I don't see a tag, that resource is gone. So you have to tag it. So I know what that resource is for. And so then you have the PI, which my model is shared responsibility. There is what I can do, and there is what you should do. And we have to agree on that. So the budget alert goes to you. You take the responsibility. So one other thing that I would like to point out is most cloud providers give you tools to uh, manage the resources that you have. Azure, for example, there is a tool that you can use to check and see all the dependencies because some people just go into delete mode. Well, you delete one here, but you have a phantom running over there and still costing you money. So you have to use that tool. Even most of the time, this happens when people don't tag the resources that they create. Now, when you use that, you can then see, oh, this is connected to that, this is connected to that, and who created this? And then you call them out and say, hey, did you create this? What is it for? Okay, we don't need it. We don't need it. It's gone. So you delete appropriately, and you avoid all these costs that shows up left and right, and you have no idea where it's coming from. Yeah. And then, so at the level of the institution, I, as a solution architect, I'm not a cloud architect, but I do have one at Central IT that I work with. So whether it's networking, so yeah, it's just as Ken said, it's always good to go through the university because we have agreement with all these cloud providers and they have discount for that. But at our institution, so we have integrated the cloud into our system, whether it's networking, identity, access management. We've done all of that for Azure and AWS. We'll be moving to Google Cloud for that. So if you are using any of our system and you go through the university, we have various way of making sure that you are in check. And we can really advise you on what to do and what not to do. And then last point, it's always good. Don't assume that the researcher knows what they want to do. So researchers are busy. They should be doing research, not cloud administration. So don't let them do that. Let them focus on the research. And you, as a facilitator, do the facilitation, find somebody, train them, have them administer their cloud account for them. I'll leave it at that point. Yeah.
Very, very wonderful. Uttam, do you want to share some of the cost perspective from your side?
Yeah, so for us, it is cost effective when we have on-premise cloud. Especially earlier, we used to depend on third party. And also many researchers, many faculty, they need data, healthcare data for their research. So it was not easy to access. Third point is when we are handling our own data, when we are storing them, obviously security is the main concern. We are trying to follow everything. But this is also true this will make our business also. So we can think when someone needs data, we can sell our data. So that is another thing. So earlier we used to depend on third party, it was vendor dependent, but now at least we have our own EDA. They used to handle the data. They used to even making ready for AI machine learning tool those data set. So earlier, say 150 years before, whatever the data we had, obviously they for AI machine learning, we need to prepare them. So that's what they are doing. And also now, second thing I can share for with respect to my lab, as our institute is healthcare related, so I didn't get permission to connect my lab to internet. So as a result, I cannot access any resources from outside Mehari. But when I worked at Singapore, there is a lab, I think Ken may know. There is a lab called ADSC Singapore, that is a part of Illinois University lab. So there I worked on smart grid network. So at the time, software-defined networking concept was new. So there we made a test bed. So for validation of SDN in smart grid communication, then we made a test bed. That test bed is actually till that it is available. And then some students, they used to work remotely from Illinois University. And at the time we used to use VPN. But when I'm working at Mary Medical College for this lab, I'm not get any access from outside and also not getting any permission from OIT department because of security concern. So
Yeah.
obviously on-premise cloud is always better.
Yeah.
It will be more reliable. And security perspective, obviously you need to take care. And easiest way to make secure, that is you just isolate your own infrastructure from
Yeah.
outside.
Yep. Thank you.
Yeah.
And Dennis, as we are coming close, do you want to quickly share something from cost perspective, running your environment in cloud?
Yeah, I can share something. One of the things I've been like interested in is like wondering if you could like make an auto shut off feature so that you can like when you have your account and it's X and it reaches zero, it automatically shuts off the machine, stuff like that. That's something I've been like wondering about. How do you do like
That's
that? Like whether it's
really
finished or not. Yeah,
nice.
the costs can be quite high
Yeah.
sometimes. You have to really watch it like a hawk.
Yep. And we have 1 minute left, and I think I will come see if somebody want to quickly ask one question, or you guys panelists want to share some one quick note, or we will just wrap it up. Thank you, everyone. I would like to thank you all the panelists. It was good learning for me. As I mentioned at UNLV, we are exploring cloud as some of the opportunity for our researchers. And maybe I will reach out to some of you asking some of the wonderful things that you guys shared to learn a little bit more deeper on that perspective. And I think I will hand it off to Henry.
Thank you all. That was a very terrific panel. And let's give our panel a virtual round of applause. Uh, and as always, if you want to know whether people were into it, just watch the chat go by. And it was going by pretty quick. So thank you all. And let me stop the recording here.